Уважаемые коллеги, мы начинаем вторую секцию, которая называется «Синтаксис и морфология в корпусах». Я попрошу коллегу Томаша Jelíneka из Праги прочитать свой доклад «System for Syntactic Annotation of large Czech Corpora».
Okay, so we shall switch to English for a moment. I'm sorry for the lack of introduction. I shall talk about our system we use for annotating, for syntactic annotation of large Czech corpora. My name is Jelínek, and I'm from the Charles University in Prague. So, the talk, I shall talk about the automatic syntactic annotation in general, about a specific corpus, Prague dependence, which we use as a starting point. I shall present the Czech dependency parsing done yet, and then two methods I devised for improving the accuracy of parsing, mainly improving parsing by pre-processing of texts. It means by simplifying the text so that the parser can do its task more easily, and about the rule-based correction system that's applied after the parsing is done. So, the automatic syntactic annotation of corpora. Syntactic annotation of a corpus provides useful additional linguistic information. I can't go into details, but we must just need an additional layer of linguistic information can be useful for many tasks, even if it is more zero dependent, even if there are more annotation errors, it can be useful for many tasks. But if we have to annotate a large corpora, we must do the task automatically. It is not possible to manually annotate 1 million words, for example. It's completely impossible. Even 1 million is a large task, so for large corpora it's impossible. So for this task, for the automatic annotation, we have to use stochastic parsing. We don't have, and few languages do, we don't have any reliable rule-based dependency parsing. It is very difficult to devise, and even some such parsers compared to stochastic parsers are perform worse. So we use a stochastic parser. I will go into more details later. But because of this type of parsing, for the moment, the error rate is too high. It's very high, like 4 times higher than the error rate of standard morphological tagging. So, new methods for improving the reliability of parsing are necessary. I will talk, this is the main part of the talk later. So, if we use as a starting point, we use Prague dependency event. This is a well-known multi-level annotated corpus of written Czech, and it has something like 1.5 million words manually annotated on a social syntactic level, the so-called analytical layer. In this analytical layer, each sentence is represented by a dependency structure, which can look like this. The example is 3% Boba as the start in the last election he became mayor, and you see that each word, even punctuation, so each token is assigned a syntactic function, either a basic one like predicate, subject, object, and so on, or an auxiliary either depends on another token or on an artificial root, which is root node, which they refers in the sentence. So based on these data, 1.5 million words, many projects of dependency parsing, many experiments of dependency parsing were tried, and I must say that Prague dependency-driven data are divided into 80% of training data and 2 data sets for testing. And with these e-test data, you can see the results of the best parsing experiments. But I must mention we can use parser, which performs better, but it is much slower than the maximum spanning tree parser. So to annotate large corpora, we have to use a parser which performs not so well, but it is 20 times faster. Maximum spanning tree parser is the parser programmed by Brian McDonald, and it uses such a format for its annotation. So it uses just a limited amount of morphological information, part of speech and case, or part of speech and subtype. If you try to add more morphological information, paradoxically it worsens the output of the parser, so the parser is not able to cope with too much morphological information. This is why we have to rethink our approach to parsing and try to find out what could help the parser perform better. The main problem with stochastic parsing is that they use a limited training data, which is sparse. It means there is many occurrences of words which occur only once. For example, in the PDT training data, you have more than half of words occur only once. So the parser is not able to learn any useful information from that. So just one occurrence cannot help it create any modal language. So it's one of the problem, and of course the training data cannot cover the whole dictionary. There are 30,000 different noun lemmas in PDT, and in the Czech dictionary you can find easily 200,000 noun lemmas which are used. There are more, perhaps 300,000 noun lemmas in the theoretical dictionary, but 200,000 are normally used. And the morphological information, as you saw, is not doesn't really cover all the necessities. So our solution, the first of the solutions, is to pre-process the text, condense data, change the data we give to the parser so that they are not so complicated, less varied, and so the parser can learn the system more easily. What we do? We replace what is the first approach. We replace word forms used in the original settings by lemmas. This is quite an easy change. But what is the main task? We try to find word classes, a list of words, which have exactly the same syntactic properties. I will show you some examples later. So, and in these lists, we choose one representative and replace all the members of this list by one representative. So later the parser can learn much less problems in the text. You can see, for example, we have a list of given names like Jan, Petr, Pavel, Josef. We replace all these given names by one representative, for example, Jan. And so on. We have Mom, same syntactic properties. It means same gender, same number, and so on. We can replace them just by one representative. So a sentence like Vladimír Petkovič jel do Moskvy, Vladimír Petkovič went to Moscow, will be changed to Jan Novák jel do Prague. The text is less interesting, does provide less information, but it is more simple for the parser. And we keep, of course, the information somewhere else, and when the parsing is done, we give back the information, so we reconstruct the text, but with a better syntactic annotation. We change in a similar way, we replace many groups of adjectives, numerals, and so on. It is more difficult with verbs because they have many potential or obligatory dependency frames and so on, but we change some verbs as well. The result for now is a reduction of variability of about 20%. The number of different forms decreased by 18%, number of different lemmas decreased by 19%. The result is the accuracy is much higher, the resulting accuracy. Well, we use an improved morphologic tagging as well, but there is a big group of more than 1% of the accuracy done by the parser. So this is the first method. It works well, and it is possible to develop it further, which we are doing. There is another system we tried to build. It was an independent work before we started the method I described now. It is a rule-based correction system. So after the parsing is done, we apply a completely rule-based system which identifies errors, tries to choose a correction algorithm, and corrects either the syntactic annotation, depend-ency relations, functions, or morphological tags. We have implemented 26 different correction rules, such as this. We have a syntactic structure which is not correct. The sentence at that moment, tu chvíli zazvonil telefon a Richard se ohlásil. At that moment the phone rang and Richard answered. It is here the parser misidentifies the coordination and thinks there are two nouns coordinated. In fact, each noun should be subject of another verb. So we devise a system, a rule that corrects it, and quite reliably changes. If it finds such an erroneous structure, it can change it correctly. So the result in the beginning was not very bad. It was much less. The improvement was not as big as the one I showed in the later experiment, but we achieved some improvement in unlabeled attachment score and a bigger improvement in labeled attachment score. But when we tried to combine these two methods, so we first used condensed data, reduced variability trained the parser. So we had this better input. After the correction rules were applied, the result was almost none. Because the parser already did a better job, our rule-based system did not perform very well. So the conclusion is there are two approaches. We have found two approaches, there are many others, but we have tried two approaches to improving parsing. One of them is the data condense procedure, which is promising, which is much less labor intensive, and it can be used with any parse. And there was another system, a rule-based correction system, which we think now can be used only as a complementary system. It is much more labor intensive, and it is necessary to adapt it to the parser and its precise settings, so that it really finds the errors frequent in this setting of the parser and not other errors it doesn't, the parser doesn't really do. Thank you. I use the settings. I use the normal use. The MST parser you can find on the internet, so the newest version. But there are settings used for Czech that I just took from my colleagues that did the job before. So both.
The second question is as follows. Still, even with the improved figures, the error rate is quite big, so you have to validate that to edit everything manually. So what's the difference whether we have 5% of correctness or 75%? You still have to manually check everything.
I don't really have to manually check everything. When I work with a large corpus, I have to check the results when I find something, but
you believe that it's okay?
I have quite a lot of big computer results, even if something I have to discard. Yes, but yes, the difference is not very big. I have shown this as an approach. I hope we can still improve the results. But, of course, they will never be as good as the morphological tagging, which can reach 96% of accuracy. It won't be used, it won't be reached by syntactic annotation, of course not. So, yes, when you will rate your work with a large corpus annotated syntactically, you will have to think about take into account that a big part, 10, 15, 20% may be wrong. But one more thing, most of the errors of the parser are concentrated in less frequent phenomena. Because the parser creates a model of the language. If in the training data he has a phenomenon which occurs frequently, he can learn it quite well. But then there are some phenomena like complicated coordination and so on, which occur not so often, and then the parser doesn't learn well these phenomena, and then it will have more errors in the results. So, if you then work with a large corpus and you concentrate on phenomena well-known or frequent, you will have very few errors. And if you work with something more complicated, you will have to check everything manually. Yes.
I think the last question concerns your condensed data.
Yes.
If you condense these data, so substitute some personal name for all other names, what happens with ambiguity, which is specifically for a particular verb form and not for the class? What happens with that?
Well, I the morphological annotated and lemmatized text. So the ambiguity is already eliminated.